Check out the finishes on this titanium part. So this is the Titan 1M that we made out of titanium on our SYIL X7 for the Boombastic event. Over here is aluminum that we ran on the X5. Now, as y'all know, we've been putting these machines through their paces over the last few months, machining everything from aluminum and steel to titanium and Monel. And our expectations have been blown away by these machines. We've been getting a lot of questions about the basic functionality of these machines. If you're a new machinist or you're a seasoned machinist, then you've never seen a SYIL with a Syntec control before. Today, we're going to go through some of the basic operations so you can see just how easy it is to run one of these machines. Now, before we get started, we did a walk around video of this machine. In that video, I did an overview of all the different screens that you're going to see here today. Go watch that video if you need to know what these different screens are. And by the way, we are the national distributor for these SYIL machines. So if you're interested, we'll leave a link in the description below. So let's get a couple tools put in the machine. Now, the best way to go about this is to put them in the spindle and let the machine take them to the ATC. So the first tool we want to put in is this 2-inch face mill. Now, this is going to be tool 1 in my program. So as you can see on the control, we have tool 2 currently in the spindle. So we need to call up tool 1 and then get this tool put in the spindle. So we can do that a couple different ways. The first way is using MDI. I'm simply going to go to MDI mode, and then we'll go to our monitor page. Now, to do that, I see the MDI screen come up. Now I'm going to select MDI input, and I will type in the command that I want to run. In this case, I'm going to type in T1 for the tool number and M6. Now, M6 is the actual code that runs a program in the background. You don't see it running, but it runs in the background to actually change the tool out. So once I type in the command that I want, I'm going to hit OK, and I see it populate into my MDI screen. Now all I have to do is close the door and hit cycle start. Close it, cycle start, and it's going to run that operation. Now once that's complete, now you'll see that tool 1 is in the spindle, and I can now put this tool in. So I'm going to hit F4 to open my door. And you've got this button here on the spindle itself that when you press, it unclamps the drawbar, and then when you release it, it clamps it back. But notice how it doesn't work. That's because we are in an automatic state. So if you're in auto or MDI, which is an automatic operation, it's going to disable that button. So we're going to need to go to MPG for our hand wheel or jog or some type of manual operation. Now we can come over and hit the button, and you hear it unlock that spindle. When you release it, it clamps back. Now, this is a BT30 machine. So with a BT, it doesn't matter which direction I put this in the spindle. It can go either direction. So I'm gonna hold it, put it in, release it. Now the spindle's got it, and we can go on to our second tool. Now for our next tool, we could go through that same process, but I'm going to show you an easier way and the way that I prefer. So if we go over to our WCS tool page, which is our offset page, we get this button called tool change. So we hit that. Now it's going to want to know what tool would you like to change to. In this case, we're going to hit 5. Now we see it populate down here, but we've not actually inputted in yet. So if that is correct, we're going to hit enter. Now we say we want to change to tool 5. So all we're going to do is hit this button, exchange T. But before we do that, we're going to close the door. That's a good safety measure. So we're going to hit exchange. It's going to call up tool 5 into the spindle, and you see it down here. Tool 5 is going to be my thread mill. Now I can open the door, do the same process as I did before. I'm already in jog mode, so I don't have to change the mode. So I'm going to press the button, put the tool in. And that is how we put tools in the machine. Next, let's go through the whole process of how to touch these tools off using our TTC 200 automatic tool setter. Disclaimer here, guys, when we partnered with Siemens back in January, I really didn't like how the tool setter macros were written. So we worked with SYIL back and forth on rewriting this process to make it a little more streamlined and a little bit more like you would typically see in a machine shop. So if you purchased a machine prior to us partnering with them, or let's just say prior to this video, then you want to double check and make sure that what you're seeing on your machine is the same as what I'm showing you here today. If it's not, then we need to get you updated to what I have now. Now, we do have files for that, so if you let us know, we can get that to you and show you the process to get you updated. All right, so let's get back to it. Now, your tool setter might look a little bit different than mine. If you haven't seen the video, we made a removable mount for our tool setter, so when we're not using it, we can move it out of the way. And then when we want to, we can just pop it back on, put our little cover down, keep the chips away from the magnets, touch our tools, and then take it off again. So let's just go ahead and touch the tool off that we currently have in the spindle, which is tool 5. So this is just a small thread mill. The diameter of it is smaller than the stylus on my tool setter. Now that stylus is a 1/2 inch diameter, or 12.7 millimeters. That's going to be very important later on. I'm already here on the tool offset page. Now I can get off of here, come back. As you see, I'm on this WCS tool page, and I have a button right here that says tool setter. Now when I hit that, it's going to say, okay, what do you want to do? Do you want to calibrate? Do you want to do a center cutting tool? Or do you want to do a non-center cutting tool? This is like a face mill or something like that. Or a tool that is larger than that diameter. Well, I know that this tool is smaller, so I'm going to do a center cutting tool. When I select that, I see my screen change. First, it wants to know the tool offset number. Now, this is going to default the H value, which is your height offset for that tool. It's going to default to whatever tool is currently in the spindle. So you want to verify that those are the same. Now I come down to see measurement type. Now if I hit enter, I get this fly down. Okay, do you want to do length only? So you only want to measure the length? Or do you want to do the length and diameter, which is L plus R? Well, the only thing I want to do right now is the length. So I'm going to highlight that and hit enter. Now it's going to ask me for the approximate tool length. I'm just going to take a tape measure, and I'm going to roughly measure from the bottom of the spindle down to the bottom of the tool. And I can see this is about 4 inches. It doesn't have to be exact. As you can see, I'm using a tape measure. We give you about a 1/2 inch buffer there, and you'll see why this is important in a minute. So approximate tool length, I'm going to put that in, 4 inches, and hit enter. Next is it wants to know a spindle rotation. Now some of you seasoned machinists might think this is odd to be able to turn the spindle on when you have a centric tool, or a tool that is smaller than the diameter of our stylus. It's essentially not needed. But I found that it's actually more accurate if you have something like a flat end mill, if you turn the spindle on rather than leaving it off, because that is how it's calibrated. So I'm just going to hit enter, and I'll get the drop down saying, yes, I want to turn the spindle on, or no. Now this is a very small tool, so I'm just going to say no. So now that we've filled everything out, we want to double check, make sure everything is correct. And from here, we can close our door and hit execute. So we're going to close our door. I'm just going to say execute. Now it's going to say it should be in the ready state. Press enter to start. So we're going to hit enter, and it's going to measure that tool. Now it's keeping the spindle off because that's what I told it. But it's going to come down at a kind of a fast feed rate until about a 1/2 inch above the stylus. Then it's going to stop and go very slow until it hits that first point. Now that is why we had to input our approximate tool length. If we had not had this option, then it's going to feed very slow from its home position, and it's going to take a long time. So to help speed that process up, that is one of the things we had to add to this center cutting tool strategy. So now that the tool is touched off, the cycle is complete. We look right here, we can see that the tool length is 4 inches and almost 25 thousandths. And we can also verify that by, if we go back to our offset page. So if I just want to go out of this and back into it, I can go to this tool set, button. Now I can see, here's my tool numbers, tool 5, there's my tool length. So now we're going to touch a tool off that is larger than our stylus. And it's also not center cutting, so it's that face mill that we put in first. So I want to go to my offset page. I'm going to hit back here. I'm going to go to tool change, and I'm going to call up tool 1, enter, exchange. There's our tool 1. Now this time when we go to tool setter, we're going to use non-center cutting. First thing we want to verify is that the H value is the same as the tool that we have in the spindle. So tool 1, H1. Next, we have the same measurement type. If we hit enter here, we can measure the length, or we can measure the length and the diameter. I'm only going to do the length. Now the one addition here is we have to enter the tool radius. The machine has to know how far to shift over to touch that edge. So in this case, that's a 2-inch diameter tool. So I'm going to put in 1 inch. Enter. And same as before, we need to know an approximate tool length. So I'm going to open the door, take my tape measure, and measure that length. So I'm going to say that's about 2 3/4. When I enter that in, 2.75, enter, it's going to work the same way as we just did, except this time it's going to turn the spindle on, it's going to shift over, and then it's going to come down, make its measurement. Now, this is where the disclaimer that I said before comes into effect. Before we had them change the macros, the first time that touched, it would not turn the spindle on, okay? So you actually had to line up one of the inserts with the tool setter. So the first thing you would do is you would line that insert up with the back, it would come down, it would touch, it would shift back up, then turn the spindle on, come back down and touch. I didn't like that at all. I wanted it to turn the spindle on. I don't want to have to line anything up, so that is how we had them change it. So when you run this cycle on your machine, if you don't see that spindle turn on immediately, just know that you're going to have to line that insert up. If not, it will pass right by the stylus and crash into your tool setter. Very important. Okay, now we have everything filled out. We've verified that everything is correct. We're going to close the door. I'm going to hit execute, and same thing, I'm going to hit enter. We see it shift over, turns the spindle on. Now it's going to come down at that a little bit higher feed rate till it's about a 1/2 inch above the stylus. Slow the feed rate down, and it's going to touch. Now note, if you've never seen this before, it's turning that spindle the opposite direction. So it's turning it counterclockwise, so it doesn't actually cut or try to cut your stylus. It's turning backwards, so it hits the back side of that insert. All right, now it's touched. We see it's 2.747, so got that calibrated eye. We can go to our offset page. We see tool 1, 2.747. Now, big note here. We don't actually have to go back out of that screen to do a tool change. Let me show you what I mean. When I go back into this, say tool setter, say I was already here on this non-center cutting tool. I just got done with that. Well, I want to do another non-center cutting tool. I can change the tool directly from this page without having to leave. It's a little bit faster of a process, but there's a note here. When I hit tool change, I get that same screen as before. Let's say I want to do tool 2 and hit execute. Now there's not a tool in there, but that's not what I'm trying to show you here. Notice if you do that from this screen, it does know that it changed to tool 2, but it does not update your offset. That is extremely important. So if you never leave this screen, make sure that you type in 2 and enter to make sure that you're teaching the correct tool length. Now if I go back out of this page and do a tool change from here, let's say I go back to 1, now I go to my tool setter page, non-center cutting, I will see that it did update. That may be something we try to get Syntec to update in the future, but for now, make sure that that H value is what you want to be teaching. So that is how we touch tool offsets using a tool setter. Now let's go ahead and put some material in this vise and go through the process of teaching work offsets. Before we go ahead and touch our work offsets off, I want to show you guys two very inexpensive tools that will completely revolutionize your shop if you've got one of these machines and pay for themselves 1,000 times over. Okay, the first thing is a tool probe standard or tool probe calibration tool, whatever you want to call it. So I love these if you've got a tool probe, because I don't know if you can see that, but it has the length and the diameter stamped on the tool itself. So it's a known length. That is very important when you're calibrating things. And we're going to use this in a minute because our second tool is a Hammer 3D taster. We don't have a spindle probe right now because one of these is all you need. And you will find that touching your work offsets with one of these tools is extremely fast. And the Syntec Control actually has a pretty cool function that allows us to use the tool length that we're going to find with this and touch our Z-axis very quickly. And that's why I'm going to use this tool probe standard to show you how to do that. To find the tool length on our Hammer 3D sensor, the first thing we're going to do is call up a tool that's not in our ATC. So I'm going to close the door and I'm going to go to my offset page, tool change, and I'm going to call up maybe tool 10. Now that the spindle is empty, I'm going to insert the tool standard into the spindle. So I have my tool standard. I'm going to put it in. All right, next we're going to take a 1, 2, 3 block or something that's a known length, and I'm going to use the table for this, and I'm going to come down with that tool standard, and I'm going to touch the top of this till it drags underneath. And then I'll know I'm directly on top of this 1, 2, 3 block. So I'm going to set it on the table. I'm going to put it in MPG or hand wheel mode. I'm going to take my hand wheel and I'm just going to jog till the tool is over the top of that 1, 2, 3 block. Now a little pro tip here, always start below the 1, 2, 3 block and work your way up in Z rather than starting on top of it and working your way down, because that could be disastrous. Ask me how I know. All right, so now I'm just below the block. I'm in Z and I've turned the resolution down just slightly because I don't want to go too fast here, move in high increments. So I'm going to start working my way in the positive direction. Now when I just slide underneath, I'm going to go down 1 click. I'm just going to keep clicking down until it doesn't go anymore. Now I'm going to switch to my finest resolution, which is 1/10. Now I'm going to go back up in the positive direction until it just barely goes under. So now I know that that tool is directly on top of that 1, 2, 3 block. And I know the length of this tool, which is why I'm using this, is 5 inches and 2/10. All right, so now that we have our tool over our 1, 2, 3 block, I'm going to come back to my control and I'm going to go to my position screen. I can see that I'm looking at my machine position. Now I'm going to hit this switch coordinate so I can see my relative position, which is not tied to anything. I can change these numbers to whatever I want. And in this case, I can go and I can zero all of them out by hitting zero all relative coordinates. You see they all turn to 0. Now that doesn't not mean anything. It's not setting a work offset or anything like that. Well, what I want to do is I'm going to type in for my Z the length of my tool right here. So I'm going to type in Z 5.0002. I can see it populate here. I know that's correct. Now I'm just going to hit enter. And I see I've changed that number. Now I'm going to move my spindle out of the way and install my Hammer 3D taster. Take this tool out. And we'll put our Hammer tool in. So now I'm going to hand wheel this back down. Put my 1, 2, 3 block under it, and I'm going to come down until I zero it out. So now I see I'm 0 on my little red dial and I'm 0 at the top. So now if I come back to my control, at my relative screen, I can see that my Z is 5.2712. That is how long that tool is. So I want to store this number because I'm going to use this later when we touch our work offset. So you can either write this number down or we can store it in our tool offset page. So I want to go to my offset page and I'm going to go to tool set. Now what I like to do here is I'm going to hit page up to see the last tool that I have access to. As you can see, we can touch off 96 tool offsets. Now I'm going to go to 95 because I like to have 96 as that tool standard. So as you can see, it was 5 inches and 2/10 long, and the radius of that tool is 250 thou and 2/10. So I want to do that same thing with this tool, but I only need the length. So I'm going to type in 5.2712, verify it here, and I'm just going to hit enter. So now I know that tool length is stored and I'll never forget it. So now we got a piece of material in our vise and we're going to touch our work offsets. And I'm going to start out with Z. So I'm going to hand jog our Hammer 3D Taster over. And just like on the 1, 2, 3 block, I'm going to find a place on the top and come down until we zero both needles. Now that we're zeroed on top of the stock, the thing about controls like the Syntec and Fanuc are they don't keep up with the tool length offset unless you have it active. So just because you change a tool into the spindle doesn't mean that that length is active yet. So we need to take that into account. So if we go to our work coordinate system page, we need to select workpiece coordinate. Now we get a new menu across the bottom. We want to set our G54 work offset. So I'm going to arrow over until I highlight my G54Z. And the X7 has this cool button called Z set. So if we select that, the first thing we can tell it is what height offset do you want to use. So remember, we stored the length that we found for this Hammer 3D sensor in tool 95. So I'm going to type in 95, hit enter. Next we want to tell it what work offset do you want to teach. Now on the Syntec control, you have two different ways that we can call G54 through G59. We can either put in G54 in our program, or we can put in G54P1. And that's what it's asking you here. What P number do you want? Well, since we're doing G54, that is P1. So I'm going to leave that at 1. Next is gauge length. So say I was touching this off on a 1, 2, 3 block and touching off on the 1 inch side. I could put in 1 inch right there to tell it that I'm 1 inch above where I want my Z0. Now I'm touching the top of the stock, and let's say I want my Z0 to be 50 thousandths below that. So I want a little bit of stock to clean up. I can just type in 50 thousandths. So basically this is the current position that you're in right now for when you teach this work offset. So now that we have all this entered, it's automatically going to take my tool length into account, and I can just select apply set Z, and I see our number update. Now this is an arbitrary number that comes from wherever the home position Z is from. That is telling you how far that bottom of that tip is from that Z home. Now one thing to note for people that own or are looking to own an X5 with a Syntec control is I have not seen this Z set button on an X5. That is literally the only difference that I have found between the X5 and the X7. So just know that it is currently not on the X5. Now let's touch X off and let's find the left edge of this stock. So I'm going to hand jog up. I'm going to come over in X, down a little bit. Now I'm just going to move back over in X until we zero both needles out. So that is where I want to teach my G54X, right on the edge of that part. So just like I just showed you, we want to highlight the offset that you want to update, and I'm just going to simply hit apply machine coordinates. And then I'm going to say yes. Now it's going to store that exact position that that spindle is currently in. But what if we want to find the center of something? So for my Y, I might find the center of the stock. I want to show you a cool little button that the Syntec control has. So first we're going to move off our part. I'm going to move forward over here somewhere, front of the stock, and I'm going to come up and find that edge in Y. Okay? Now you could do this a couple different ways. I could do it just like I did, and I can say apply machine coordinates, and then measure my part, shift positive, because I want to go in this direction. I can shift positive half of whatever I measure it, or I can go over here to my position screen. Now I still have relative called up, and I'm just going to 0 all relative coordinates. So now I know that my spindle is currently on the edge of that part, and I want to move out in Y. Now I want to go touch the other side and find that edge. So I can move up, come back over here, and I've zeroed it back out. Now I'm on the back side of the stock. And I can see that this stock measures 2 inches, 14 thousandths, and 3/10. Now I can do that with my calculator. I can half that, go to my work offset, incrementally move it, or we can use this half coordinate button. I really like this a lot. What axis do you want to half? Well, we want to half the Y axis. So what I want to do is type in Y. I see it populate here, and then I select this half coordinate. And you see it automatically halved whatever that number is. Now all I have to do is I'm going to move off this part in Y. I'm going to come over it in Z, and I'm just going to go until this is 0. So now I know that my spindle is exactly in the center of that part in Y. Now I can go back to my work coordinate page, highlight my Y, and I can do workpiece coordinate, apply machine coordinates, and hit yes. Apply it right where you're sitting because I have already found the center. So that's the basics of how to teach your work offsets on a Syntec control. Now let's look at how you put a program into the machine. Now there's a couple of different ways we can import a program into our machine. The first being we can hook this machine up to a network. Well, what we're going to do is use our USB and plug it directly into the control. So I'm going to plug into either port. Next we're going to go to our program screen, and I'm going to select my file manager. Now once I'm in here, I can see all the programs that are currently in the machine. What I want to do is select file transfer, and it's going to ask, do you want to do file import or file export? We want to do file import. Now what you're going to see here is on the left side is everything that's on my USB, and on the right side is this current NC files folder. I want to arrow down until I select the program that I want to copy. I want to say select it. You can see the little check box, and I'm just going to hit copy. Once I do that, you see it populate on the right side, and I can just hit my back button here to get out of that. And now I see the program loaded into my file manager. Same thing if we want to export a file to our USB. I just select file export. Now you'll see that these are swapped. Now I'm looking at the NC files on the machine, and over here is my USB. So I can come down, I can select, hey, I want to export this daily warm-up. I can select that, and I can hit copy. Now I see the daily warm-up here on my USB. So I can exit out of this. Now to select that program, all I have to do is hit enter. Now my program is called up, but it is not active yet. I can edit it from this screen, but it is not active to run. Now if I go to my auto button and I go to my monitor screen, you can see this is the active program that it's going to run. The 72-hour warm-up program that I ran earlier today. I also see it here at the top, the name of the program, which is the very first line that you see. Now if I go back to my file manager, I can either go back to my file manager here, let me go back to this monitor screen, or I can just go directly to my program. But you see that when I go back to my program, that program that I just imported is the one that is active. So I'm editing this program. It's not active to run. If I want to run it, all I have to do is go to execute. Once I hit execute, it takes me out of the program screen into the monitor screen, and now I see that program is called up, and I also see it right here at the top. So now I'm ready to run that program. So the last thing I want to show you guys is how to slowly step through a program for the first time using this MPG Sim button, because I can tell you right now, using this 25% rapid is not slow enough. You will crash. Your reaction time is not going to be fast enough. So this MPG Sim button is pretty slick, and I think you're going to like it. That's this button right here. And what that does is it activates our hand wheel. So I'm going to put this down here so we can see it. And you can see I've got the program called up, ready to go. So what I'm going to do is I'm going to hit auto, and I'm going to go ahead and activate this button, the MPG Sim. Now let's close the door and hit cycle start for running our program for the first time. Now it's going to go ahead and change the tool. It's going to turn the spindle on, and then it's going to stop at this first move. Now it is not moving the machine until I tell it to move with the hand wheel. So now with my hand wheel, I can start rotating in the positive direction, and you can see the machine is now moving in the program. It's going forward in the program. Likewise, I can actually go in the reverse direction, in the negative direction, and it will actually back my program up. I really like this because I can really fine tune my steps through my program to make sure that I don't crash anything. Now you might say this rapid move here is still pretty quick. So what I can do is if I turn this knob here, it doesn't have any effect on it. It's still the same speed. But if I move this knob, which is my feed rate knob, feed rate override, I can move that down to some slow feed rate. Now when I start moving forward, I can see that rapid move is much slower. So I've really got a lot of fine control over this toolpath or over my program. So I really like to use this on unproven programs when I want to make sure that my work offset's touched off correctly, or maybe I'm not really sure of my post-processor. Maybe I don't know if this code is good. So I can walk through this very slowly to make sure that I don't crash my machine. Now, if you finally feel comfortable with it, saying, hey, I've verified this, if that tool went to the right location, everything else should, I'm good to go. All you have to do is simply turn this button off, and when you do that, the machine starts moving as it normally would if you were just simply running the program. One thing I want you to understand is this button is not only for running a program. You can use this with any automatic cycle, like touching a tool off, or just simply doing a tool change. If I go over here to tool change, and say I want to change to tool 2, I turn this button on, and I hit execute. Now nothing's moving. So now I want to rotate my hand wheel, and I see that it's coming up, does its tool change. So you can step through processes like that with simply using this MPG Sim button. That's all I got for you guys today. That's some basic functionality on the SYIL. You can see how simple it is to run this machine. And if there's something that I didn't show you here today that you would like to learn, go to cncexpert.com and post on our wall what you would like to see or what you would like to know about these machines. We will answer your questions to the best of our ability. And if you haven't already, go ahead and hit that like and subscribe button. We'll see y'all next time.